Jai Hind to everyone. My name is Vikas. I'm assistant professor in CSE department. The topic today I'm going to discuss is grid computing and introduction in cloud computing. These are the outline of my presentations. Introduction of grid computing, how the grid computer works, and what are the key components regarding the grid computing are there. Grid computing, this before going to the grid computing, the concept of cloud computing come into picture in 1950, in which the at that time this concept was came because the resources or you can say the systems of computer were so huge, so it won't be possible for everyone to access those systems are there. So the phrase cloud computing was coined in 1950 to describe a system that provides internet related services and involved from the dispersed computings are there. Then this mainframe computing systems were evolved over the period of time, and it's moved towards still utility computing are there. So during that in 1990s the grid computing was proposed and developed subsequently to create a cluster computing are there. Since this grid computing structure consists of several computers or you can say nodes are there, in which these various nodes are located at the different or you can say various geographical locations are there, but they are linked with each others via the network or you can say the internet is there. During the progress of the cloud computing, which consists of all the nodes which are spread across many regions, include grid computing. So it becomes an heterogeneous nodes are dispersed through the several say companies or the several geographical locations are there. So, in order to optimize these various systems or you can say various nodes, why it is being optimized? Because in simultaneously the various nodes are used for calculating or executing various various applications, various instructions are there. So certain nodes are optimized, can be joined and accomplish the any given purpose is there. So completing the difficulty task is highly desirable since numerous computers or network nodes are involved in order to execute those instructions are there. So there are various definitions with respect to grid computing are there. There are few are there. In the grid computing for is a form of distributed computing where a super or virtual computer is composed of cluster of networks. They are loosely coupled computers and acting in concern of performing very large tasks are there. In the grid computing, we have the certain given instructions or you can say various tasks are being divided into various subtasks are there, and these subtasks are simultaneously executing those tasks is there. Once the task is being completed, that is being given to the main computer, so that main computer will display the output are there. Okay. So grid computing by the Foster and Castleman 1999 is a growing technology that facilitates the execution of large scale resources intensive application on the geographical distributed computing resources are there. In the grid computing, if we talk about the standalone systems are there, the way resources are being not fully utilized are there. So, in order to utilize those resources, the concept for the grid computing where the various systems where nodes working in tandem in order to execute the instructions are there. So, this enables the communities to share the geographical distributed resources as they pursue the common goals are. As it's already stated, the various nodes are executing simultaneously in order to complete the big task are there. Or you can say a task is being further divided into different subtasks, and those tasks are being executed by the different nodes are there. So, criteria for the grid is coordinating resources that are not subject to centralized control. uses a standard open general purpose protocols and interfaces are there. Deliverable non-trivial quality of services are there. It means in the grid computing, the centralized control is not there, that is being so we say it is a distributed in nature, sir. So benefit is we can exploit the utilized resources are there. As I told you, in the standalone systems, we are not sure that your resources are fully utilized are there. So if we say around 30% resources are being utilized, rest are being non-utilized are there. So in order to utilize those resources, we can use the grid computing there. So benefits is we can exploit the unutilized resources. We can have the resource load balancings are there, as load balancing is one of the major characteristics in cloud computing. So load balancing plays a vital roles here. Virtualization resources across the enterprises such as data grids, computer grids are there. It enables the collaboration of the virtual organizations. So generally, as a grid computing is part of the your cloud computing, in which we utilize the resources which are being left there. So this is how the grid computing works. It generally consists of the three nodes are there. One is your control server, another is grid computing, and another is users are there. Okay. So a control server is basically the clusters of computer, cluster of servers. Okay, these are the here in this we have their various servers are being kept at one data centers are there. Those servers are fulfilling the request of the, let's suppose if we have an execute the any query with respect to Java is there. If they can execute the any query with respect to .NETs or C++ clients are there. These are the various tasks are there. This is for the examples are there. Then we have grid nodes are there, where this is the systems in which we deployed the softwares which will be helpful for the grid computings are there. And the third one is your users are the user, where it provides the interface to the users are there. So typically grid consists of three machines types, as I told you: control node or server node. Control node is server or a group of server that administrator the entire network and maintain the records of the resources in the network pools are there. Another is provider or grid nodes are there. The providers of grid nodes is a computer that contributes its resources to the network's resource pools are there. And the user refer to the computer that uses the resources on the network to complete the task are there. Okay, so here in this user give the query to the your control server are there. Here this control server will transfer the request to here this grid node, and this grid nodes are there. Or you can say this transfer it to the here and transfer to, so they again transfer to the further on certain nodes are there, which in parallelly they are executing those instructions. Let's suppose we are giving the any problem where, let's suppose, JavaScript is being executed. This request will be sent to the control server give it to the grid nodes are there, where different nodes will break down this problem into the sub problems. When they execute this problem at their end, give it back and send it to the users, so that user can able to see the outputs are there. Okay. So grid computing operates by running specialized softwares on every computer involved in grid networks are there. The software coordinates the manages all the tasks of the grid Fundamentally, software segregation main task into the subtask and assign the subtask to each computer server. So, this grid computing runs on those specialized softwares are there. It is a task of the software which makes sure the task is being divided into the various subtasks, and that subtask must be assigned to each nodes or a computers are there, which parallelly they can execute. After executing it, again those tasks are being merged to the main task and provide the results to that. So, this allow the computer to work simultaneously on their respective subtasks are there. Upon completion of subtask, the output of the all the computers are aggregated to complete the larger main task are there. Okay. So, it means let us suppose this is your main task is here, and now it is being into grid computing. First it divides first divided into various different tasks are there. Here this node will execute this problem. After executing these problems, now they will give back to the main computer again, so that where the output can be displayed to the users. So, this is let us take an example. We have been considering where x is equal to this is a simple problem is there where x is equal to 4 into 7 plus 3 into 9 plus 2 into 5 are there. Typically, if we use the simple standalone desktop computers, or you can say laptops are there, we need to calculate the value of x, maybe look like this. On the step 1, as we know by using the board mass, we have to execute the instructions which are kept in the bracket first are there. Then one by one we can calculate it. So, 4 into 7 28, 3 into 9 27, then 5 into 2 is 10 are. So, this is the value is there. Now, this value is being added and given to the 65. So, this will give you a result. However, in but if this let us suppose this simple calculation has to be done in a grid computing, then how it going to do it? In the grid computing, the setups steps will be different as comparatively to these steps are there. So, in order to do that, the computer calculate the different piece of equations separately, and after executing those instructions, they will merge again. So, okay. So, as this, if we see it, we need this is the one large problems is there. Now, this problem can be this in the grid computing. This instruction will be given to the one node are there, then this will be given to the another, and this will be given to the another nodes are there. So, when and parallelly they are being simultaneously they are being executed. Once they are being executed, they will show deliver the result in 2 steps are there. Okay. However, in the desktop computing, it takes 4 steps, 1, 2, 3 and 4 are there, but in the case of the grid computing, we can execute this simple linear expressions into 2 steps are there. So, this is how the grid computing works are there. It means in a grid computing, we have different systems, different nodes, different computers are interlinked with each other, or you can say they are connected to each others via the internets, and they are kept at different geographical locations are there. When any instructions came up, that instruction or any problem need to be executed, that will divide into various subparts. After dividing the subparts, it is given to the different computer, different nodes which are connected to with each others or the networks are there. They execute it in parallelly and send it to the after executing it, they send back to the output to the your main nodes. That main node will display the output to the users. This is how the grid computing works. So, there are the various components that are being used in the grid computings, or you can say the key components for the grid computings are user interface, security, scheduler, data management, workload, resource management is there. Here user interface, it means the user can able to access the informations easily is there. Security is one of the major concern in the cloud computing. So, in grid computing also is there, whether the data is being properly secure, as we are dividing the task into subtasks, and those subtasks are being given to the various nodes or computers which are located at different geographical locations are there. So, security is one of the major concerns in or we can say key components in the grid computing. Scheduler which will make sure which tasks to be executed, then the data management workloads. Let us take one by one, these are there. So, as we user interface, if we talk about user interface, most of the applications nowadays in the cloud computing are accessed by the web portals, webs. Okay. So, at these web portals, they provide the single interface, allow the users to view wide variety of the informations. Similarly, grid portals offer an interface that enables users to launch application with the resource provided by the grids. So, in this, as we already know during the here that your grid nodes, we have the your control nodes have the administrator of entire networks, and the grid node provides the computer that contributes in order to pooling of the network resources are there. In similar fashion, we can say the user interface is plays a pivotal role here, in which the applications of the grid computing can be accessed by the web browsers are there. They provides the single view, or you can say single view of the applications, so that user can generate a query, get the informations, get the output which is being needed are there. Okay. So, grid users views on a single large virtual computer offering computing resources are there, similar to internet's used who view your unified instance of content on the web server. It means just like in your web browsers, when you access any website, you can access any content, you can see any audio, video, everything is there. In the same fashion, we can use the grid computing applications with the help of the web browsers are there. Another key components is the security is there. Security is one of the major concern here. Why it is being major concerns? Because the data or instructions are being are not executed at the same systems. They are being executed at the different systems or nodes or computers are there. So, we need some authentications, authorizations and encryptions that are being needed. Why it is being needed? Because only authorized nodes can able to execute those instructions. For that we need to authenticate, are there authorization must be given to them, while sending the subtasks that must be encrypted, or you can say masked, those data is there, so that over the internet nobody can able to see those informations are there. So, here in this grid computing, the GIS, that is grid security infrastructure, plays an important roles here, or you can say it is an important ingredient here. It's the out task is to outline the specifications that establish secret and tamper proof communications between software entities operating in the grid networks are there. So, it generally uses the open SSL implementations, which provides the single sign-on mechanism for the user to perform actions with the grid. It offers the robust security by providing the authentication and authorization mechanisms for the system protections are there. Okay. So, security is one of the major concern, or you can say is a key component in the grid computing is there. Without this, your data will be lost. Anybody can access the informations. So, we have to make sure during while data is being sent across the in the grid computing, the data must be secure enough for us. Another is scheduler is there is the key component. The basic task of the scheduler is to identify the resources which needs to be run next in the next step, or you can say which needs to be done in the near futures are there. Schedule may not be needed if the standard tasks are to be executed that showcase no any interdependencies are there. It means a task is not subdivided into various subtasks. However, if you want to run specific tasks that needs to be executed concurrently by the and in order to require inter-process communications. So, at that time we need require schedulers are there. So, moreover, the scheduler is what is a different level of operates, and also it's operate on different grid environments are there. There are high level schedulers are there, there are low level schedulers are there. These schedulers works independently. What depend upon the at what levels are there. So, cluster may represent independent resources with own scheduler to manage the nodes it contains. Hence, high level schedulers may sometimes be required to accomplish a task done by the clusters, while the clusters employ its own separate scheduler to handle work on its individual nodes are there. Okay. So, there are two schedulers are being needed. Locally, local schedulers must be needed for the execution of the subtask are there, or you can task are there, and if the task is being given to from the higher level, at that time they also need the high level schedulers are to be needed are there. Okay. So, schedule is another key components in the grid computing are there. Another important key components are the data management is there. So, data management is one of the crucial, or you can say important or crucial in the grid environment. That data, as we have to travel from one node to another nodes, one computer to another computer over the internet, the grid computer need to make sure that it is secure and reliable in nature is there. So, they need to create such a mechanism so that the data can be accessible to various node within the grid, in order to make sure that in order to do it, they generally uses the open source toolkits, and that is Globus toolkit is there. It offered data management components called the grid access to the secondary storage. It includes the grid FTP built on the standard FTP that is being used for the file transfer protocols are being used there. And it utilize the GSI is there, that is grid security infrastructure are there. Okay. So, this is the grid security infrastructure is there. So, by utilizing the GSI for the user authentication and authorizations there. After authentications, the user can move files from the using the grid FTP facilities without going through the login process at every nodes are there. So, this way they helps in better data management over the grid computing server. Another is workload and resource management. In this, as with the help of the schedulers, the tasks are being sent to the various nodes are or computers are there. So, in order to we need to make sure the all the resources or the net in the grid computing must be properly utilized. And workload must be shared equally among the various different nodes are there. So, in this case the application should be aware of the available resources on the grid that take up the workload are there. So, in order to do it, we need to interact with the workload manager to determine the resources and availability of the updated status accordingly. These are the grid computing types. We have a grid computational data grid, collaborative grid, manuscript grids, modular grids are there. Let's take one by one. This computational grid finds the application on the several real life scenario. In the computational grid, we can speed up and business report generation for a company with the online marketplace are there. It is very important factor for customer and the company. For the company, they can use the grid to generate the reports within the few seconds rather than minutes are there. Another is data grid computations, which refer to splits the data into multiple computers, like computational grids are there, where the computations are split. Data grid enables placing them into the networks or the storage are there. So, grid virtually treats them one despite the splitting over the networks are there. Collaborative grid is another application which solves the problem by offering the seamless collaborations are there. In this individual, the type of computing uses the various technology that support the work between the individuals. Individual workers can readily access the each other's works and critical information on times are there. So, in order to increase their productivity and creativity, which will benefit the organized massively is there. Another manuscript grid computations come in handy when the managing large volume of the images and text box are there. In this type of grid allow the continuous accumulation of the images, text blocks while processing the performing the operation on the previous block batches are there. It is simple grid computation framework where the various volumes of the text, manuscript, images can be processed parallelly are there. Then we have modular grid computing, which is related to disaggregations, computing resources, system of chassis, where the resources can be include storage, GPU, memory, and etc. Fundamentally, modular grid is a set of resource combined with the software for a distinct applications are there. So, this is the typical view of grid environment. We have a grid information services are there here. This is the grid resources. We have a grid resources cluster of systems are there here. The cluster of systems are there. We have this will have the resource. This node will have the grid information service is there, which collect the details of various clusters are there. They store it at this main node, and the user can access this grid applications or you can say grid node with the help of the grid applications are there, and it send a request to them. They send it to the this cluster of computers are there. When they process simultaneously given to this main, and then this computational result is sent back to the users are there. So, here this generally is act as a resource brokers for the various distributions are there. These are some of the major grid projects are there. We have a Eurogrid interpretive which is used for the creating tech for the remote access of supercomputers are there. Here fusion collaborative is being used for the national computational collaborative fusion research. Again, we have grid research, grid PP, grid lab, grid projects. These are the various projects are being running right now, which will help in order to establish the grid computing. Thank you.